The periodic table lists all the substances in the universe that have only one type of atom in their makeup. Countless millions of other substances are made from combinations of these atoms. When atoms come together, they form bonds, and the resulting molecule or compound has a whole new set of chemical and physical properties. So let's look at chemical bonding and start with the most abundant atom in the universe, hydrogen. The element hydrogen has one proton and one electron, making it quite simple. The proton is positively charged in the center of the atom, and the electron is negatively charged and occupies a larger space outside the nucleus in the form of an electron cloud. This electron cloud surrounding hydrogen is often called an orbital. It is basically all the places where an electron has a chance to be found. Now let's bring another hydrogen atom into the picture. As we slowly start moving them closer to one another, we will show their combined energy on this graph. For a while, nothing changes. And then as they get close enough together, their energy starts to drop and eventually hits a minimum. And this makes the combination stable. This minimum energy distance between them is called a bond distance. And they are now sharing electrons. This is called a covalent bond. And instead of having two individual hydrogen atoms, we now have an H2 molecule. Moving the atoms any closer increases the energy greatly, since the positive protons in each of the atoms are repelling one another strongly. Covalent bonds come in different lengths and strengths depending on the atoms involved. These bonds are often shown as posts, lines, or dots between atoms. But of course, these are simply representations of places where electrons spend their time between atoms. In a covalent bond, electrons are shared, but they aren't necessarily shared equally. Let's take one of the hydrogen atoms and replace it with a fluorine atom. Watch what happens to the electrons throughout the atom. Fluorine, by its very nature, has a stronger pull on electrons in this molecule than does hydrogen. Fluorine shares electrons, but not equally. Instead, it pulls electrons closer to itself than to hydrogen. This is called a polar covalent bond. Each element in the periodic table has a tendency to pull electrons towards itself in a bond. This property is called electronegativity. When you alter the periodic table to show electronegativity, it looks a little different. Notice that elements on the left-hand side of the table, metals, have very low electronegativity values. They don't pull electrons towards themselves at all. As a matter of fact, they willingly give them up entirely. Table salt, as we know, is made up of sodium and chlorine, and so it is called sodium chloride. In forming table salt, the sodium atom gives up an electron and becomes positively charged. The chlorine atom picks up the electron since it is more electronegative and becomes more negatively charged. Now a very old saying takes over: opposites attract. So here, the atoms are drawn towards one another by their positive and negative charges. If there are enough atoms, we can eventually wind up with something as big as a single salt grain. This kind of bond is called an ionic bond. it has a very strong attraction between positive and negative ions. Most people differentiate this from a covalent bond by saying that in ionic bonds, electrons are exchanged instead of shared. Ionic bonds are very strong, stronger than covalent bonds. And you can easily see this difference. Melting sugar, which is breaking a covalent bond, is simple and makes caramel. Melting table salt is very different and requires temperatures higher than 1400 degrees Fahrenheit. Ionic bonds are very stable bonds. Very important, and much weaker than ionic or covalent, is a hydrogen bond. When hydrogen atoms connect to a small, strongly electronegative atom like fluorine, oxygen, or nitrogen, the resulting molecule pulls the electrons so strongly to the larger atom that the hydrogen nucleus, its one proton, is essentially exposed on one side. So it will bond to the negative side of any similar polar molecules. This bond is called hydrogen bond. The difference in strength of the different types of bonds is fundamental to allowing the DNA molecule to replicate itself. The bonds that hold the opposite sides of the double helix together, the A's and the C's and the G's and the T's, are hydrogen bonds and are very weak compared to the bonds that hold each letter to the backbone and the bonds that hold the backbone together. This allows the molecule to unzip easily, to expose one side as a template for replication. Life is all about bonds. Bonds, chemical bonds. Who knew?